Welcome everyone to Where Will I Use This? Today we're going to talk about statistics, the very mention of which puts most reasonable people to sleep. Statistics is the secret to wealth in the modern age. Think of Facebook, of Google, of Apple, all the big tech companies out there making massive fortunes. They are using statistics to parse through data that they collect from you who use their platforms. This is a huge industry, and it's all based on one of the most boring sounding mathematical concepts of all, especially when you start out. When you start out statistics, you don't learn about how to make billions of dollars. You learn how to take the average of 5 points of data. So how do these simple statistical concepts make their way into your everyday life? Let's talk about it. The most common examples of statistics in school are coin tosses, card games, anything really to do with gambling. And that's because they're easy examples of things that have the same outcome every time. If you flip a coin, it's just a 50-50 shot, right? Everyone knows that. But these simple concepts can be used in much more meaningful ways to describe the world around us. And you don't need to be a PhD to understand how that works. We're going to use relatively simple concepts to explain wealth inequality in the United States, racial bias in loan decisions by banking companies, and we're going to teach you how to spot potential fake statistics so that you are not fooled by somebody trying to make their numbers sound right. On to wealth inequality, possibly one of the most talked about things ever in human history. Why do some people have more and some people have less? And are the people who have more getting even more, while the people who have less are getting even less? To explore this topic, we're going to use two very basic statistical concepts. The mean, or the average, I'll just call it the average for this video, but it goes by two names, and the median. The difference between the average and the median is very interesting. Take these two very simple examples. On one hand, we have three people all making $50,000 a year. Their average is $50,000, and their median is $50,000. But over here, we have three people making different amounts of money, with the person making the most at $1 million a year. The median is still the same at $50,000, but the average is over $350,000. It's this example that sets the stage for this graph of the mean versus the median household incomes in the United States from 1967, when they started taking this data, up until 2018, the latest year for which this data is available. And you can see in this graph that these two lines are diverging. They're getting farther apart as time goes on. They're both trending upwards, but the mean is increasing more than the median. If you think back to the example we just went through, the likely cause of this is that the people at the top are making more money than the people at the bottom. That's making this gap widen. And this is often referred to as the wealth inequality gap. Now, we should know that this is not definitive proof of the rich getting richer and the poor getting poorer. There are a lot of other factors to talk about behind this data, but understanding the difference between the average and the median in this graph can get you on your way to an intelligent discussion about wealth inequality. Let's now take a look at how banks loan money. If you want to get money from a bank, you have to go in and give a reason for wanting that money. You have to give them all sorts of personal information, such as how much money you make per year, how much debt you currently have, what your assets are if you own a house, if you rent, if you own a car or if you lease, those are all important things that a bank wants to know. Banks use automated tools very often to make these decisions. It's how you can get approved for a credit card on the internet by just typing in a few numbers. While the math behind these algorithms is pretty tricky, you don't need to understand it to get a feel for how these algorithms work. On the screen is an example of a predictive analytics tool called a decision tree, and it does exactly what this graphic represents. You move from the top, where you ask about a loan decision, and based on the information you give, you either deny or approve the person for the loan. In this simple case, we just want to know whether they make over $50,000 and own a house. Banks likely use more complicated predictive tools than just a decision tree. But this model represents very well visually what is happening behind the scenes in that algorithm. It's all about putting in information about a person and getting out whether or not they should be given a loan. Now, where does racial bias fit into this? You could imagine that it would be pretty easy to add a column of race to this decision tree. And you could make your decisions based on someone's race outright. But could you imagine the backlash that a bank would face if anyone ever found out that they did this? No, it's very unlikely that your local bank or even national banks are using race overtly in their programs. Instead, racial bias may be present in these programs without anyone necessarily putting it in there. I'll explain what I mean. Let's say the bank wants to know your home address before they give you a loan. They could input, say, your zip code into their program. If their program uses the zip code as a deciding factor, and there are certain zip codes which contain more minorities, there could be racial bias in that program without it being explicitly labeled. This kind of bias is very important to understand because it's difficult to see, difficult to understand, and it's everywhere. This is what we're up against in the fight against racial bias. Cold, heartless algorithms. Algorithms which may be racially biased, even if their human creators do not intend them to be. Now that you are a more informed citizen, let's talk about ways that you can recognize deception in statistics. Statistics are very often used to deceive people. It's very easy. You could just make a graph. You don't even need to tell people where the data came from. You could just make a graph. Obviously, those graphs don't get a lot of credibility, and institutions go out of their way to make sure that their data is reliable, just in case somebody wants to come in and try to prove them wrong. But let's say the deception is not about making up data. It is about playing with the data that exists. It's hard to argue with a peer-reviewed, published scientific work. Statistics will often reference these because they're very credible sources. But what often happens is a statistic will just reference a study, as if a study somewhere in the ether backs up what they're trying to tell you. That is a red flag. It does not necessarily mean that that statistic is wrong, but it is a red flag that this statistic may be trying to deceive you. Another important thing to look for is whether or not the graph scale has been tampered with. Often, tampering with the graph scale is used to make differences in data look bigger than they really are. Now, the more observant of you may have realized that I did this with my previous example. This graph of the average versus median income was tampered with. I started the graph at $40,000. I did not start it at zero. This is what it would look like if it were started at zero. You can see that the difference between the average and the median is not nearly as pronounced as it looked when I messed with the scale. Beware of this because this can be used to great effect to deceive you in statistics. Now, I didn't change any of this data. It's all exactly the same. All I did was chop off this bit of blank space down here and make the graph look bigger than it really is. Another red flag for a deceptive statistic is whether or not it seems alarmist. Does that data make you angry at something or someone? Again, that's possible, but it is a red flag that this statistic is trying to deceive you by appealing to your emotions instead of appealing to the science and the underlying cause of that data. The last one I want to talk about is also a very good life lesson in general. If a statistic is trying to sell you something, if it's trying to get you to spend money, big old red flag right there. Just be suspicious of any statistic or anything in your life that's trying to sell you something, because they have a motivation to sell you something. They're not motivated to give you the truth. They're a company trying to sell their product. It doesn't mean that their statistics are necessarily wrong, but guaranteed they tried their hardest to make it represent their product the best. They did everything they could to make their product look better than the competition. That's deception, even if it's not outright lying. None of these factors automatically disqualifies a statistic from being real or from being useful, but you should be careful that you don't make big life decisions based on data that you don't necessarily trust. To answer the question, where will I use statistics? You will use it to help understand and fight racial inequity, to help protect yourself from deception by others, and to better understand the world around you. The next time you see a number come up on the news, question it. Thank you so much for watching, and have a nice day.